Hey there, science fans. We use a lot of energy and things can get really hot. That's why we need smart ways to manage all that heat. That's where CPCMs come in. CPCM stands for Composite Phase Change Materials. These amazing materials can absorb and release heat like nobody's business. Imagine ice melting. It absorbs a lot of heat without getting much hotter itself. CPCMs work similarly, but they can change between solid and liquid states at various temperatures. This makes them super useful for storing and releasing thermal energy. They're like tiny rechargeable batteries for heat. CPCMs are already making waves in different fields. They can help us save energy in buildings, keep our electronic devices cool, and even transport medicines safely. Pretty cool, right? But there's more to these thermal superheroes than meets the eye. Let's dive deeper and explore the world of shape-stabilized CPCMs. Now, regular CPCMs are great, but they have a little quirk. When they melt, they become liquid and can flow around. This can be a problem in some applications. That's where shape-stabilized CPCMs come in. Think of it like this. Imagine a sponge soaked with water. The sponge holds the water in place even though the water itself is liquid. Shape-stabilized CPCMs work similarly. They have a solid structure that holds the phase change material, even when it melts. This is where things get really interesting. By combining the right materials, scientists can create shape-stabilized CPCMs with different properties. They can control the melting temperature, the amount of heat it can store, and even its flexibility. This opens up a whole new world of possibilities. We can now use CPCMs in even more applications, from flexible electronics to smart textiles. Talk about a hot topic in material science. So, what makes these shape-stabilized CPCMs so special? The secret lies in their structure. They often use carbon-based materials as a support system. Think of carbon as the scaffolding that holds everything together. These carbon structures are porous, meaning they have tiny holes that the phase change material can fill. Carbon-based materials like graphene and carbon nanotubes are like the superheroes of the material world. They're incredibly strong, lightweight, and excellent heat conductors. This means they can make shape-stabilized CPCMs even more efficient at storing and releasing heat. Plus, they help prevent leakage of the phase change material, even when it melts. It's like having a leak-proof container for all that thermal energy. Section 4. CPCMs in action. From buildings to batteries. Ready to see shape-stabilized CPCMs in action? Buckle up, because these materials are changing the game in a big way. Imagine buildings that can regulate their own temperature. CPCMs embedded in walls and roofs can absorb heat during the day and release it at night, keeping the building comfortable without cranking up the AC. That's a big win for energy efficiency, but that's not all. Shape-stabilized CPCMs are also helping to create safer and more efficient batteries. By absorbing excess heat generated during charging and discharging, they can prevent overheating and extend battery life. And remember those life-saving vaccines? CPCMs are playing a vital role in transporting them to remote areas, ensuring they stay cool and effective. Section 5. A cool future with CPCMs. Challenges and opportunities. Shape-stabilized CPCMs are amazing, but there's always room for improvement. Scientists are constantly working on making them even better, exploring new materials and designs. One challenge is to find the perfect balance between heat storage capacity and thermal conductivity. We want CPCMs that can store a lot of heat and release it quickly when needed. Another area of research is to make CPCMs even more durable and long-lasting. We want them to withstand countless cycles of heating and cooling without losing their shape or performance. The future of thermal management is looking bright, thanks to shape-stabilized CPCMs. With their incredible potential for energy efficiency and beyond, these materials are poised to revolutionize the way we live and interact with our environment. Keep your eyes peeled for more exciting developments in the world of CPCMs.